So what you see here is the largest previous network that was compiled by Kaiser and Hilgedag in the macaque monkey brain. You can see the thalamus and basal ganglia are completely absent on the right side, and there are huge holes in the cortical connections as well. And our network is 3 times bigger than the largest previous network. So in a certain sense, our network is comprehensive, consistent, concise, coherent, and colossal. And I'll point out how this network actually gives a clue into higher cognition and perhaps even consciousness. Now first, some statistical analysis. Once you have a network, just like we know how to mine the web graph, we know how to mine the social networks such as Facebook and so forth, we can mine the brain. And what you learn very quickly is that the brain is small world. Okay? Also, you see that the diameter of the brain, which is the length of the longest, shortest path between any 2 brain regions, is 6, which means that the brain has exactly 6 degrees of separation, which is a very surprising and an interesting finding. Now, if you further divide major areas of the brain and compare them against one another, how many connections are from visual cortex to parietal lobe? How many connections from thalamus to basal ganglia, so forth? You see that you cannot really entangle this table into some sort of a block diagonal form, meaning that the brain should be studied as a whole. It cannot be studied in piecemeal. Okay? It's like the 6 blind men feeling an elephant. You have to see the big picture. Now, as you begin to see the big picture, the first question one can ask is, what is the degree distribution of this network? A leading camp wants to believe that it's the power law, because we found power law in so many places. That's a Zipfian distribution. And what you see in front of you is the white line denoting the power law hypothesis. On the next slide, you see a white line showing the exponential distribution hypotheses. So the data seems to rule out the possibility that the brain is a Zipfian distribution in the long distance network, and seems quite consistent with the maximum entropy exponential distribution hypothesis, which is just one parameter. It's a very simple distribution, and it seems to fit the data quite well. So what this means is that brain is much more like resource-constrained physical networks, like the power grid network, the air traffic network, the network of board of directors of companies, and is much less like the resource unconstrained networks like the Facebook, where you can have an arbitrary number of friends. So going forward, now you can say, okay, it's the exponential degree distribution. How are some areas more important than others in the connectivity of the brain? So what we did is we analyzed this network according to a large number of ranking functions, one being the page rank used by Google for web ranking. And of course, you can do in degree, in closeness, out degree, out closeness, so forth. And of course, I don't expect you to know different nomenclature for the area, but let me color code it for you. All the regions in yellow are in the prefrontal cortex. Now, prefrontal cortex is not physically central, but this indicates that it is topologically central, which sort of provides quantitative evidence for a long-running hypothesis in neuroscience. So now let me tell you about the most amazing finding. Is we wanted to study this network and understand if there is a group of brain areas that somehow collaborate with one another to subserve as an essential subnetwork of the long-distance wiring diagram of the macaque brain. And so we went back to an algorithm called coreness. which peels the network much like you peel an onion. The idea is this. You want to find who is central, but centrality cannot be unambiguously defined. So perhaps you can begin at the other end. Who is peripheral? So one definition of peripherality is if you have, for example, very few edges either originating from you or terminating in you, you may be peripheral. If your degree is 1, you may be peripheral. So the idea is you peel out those vertices that have degree 1. Then the network has only vertices that have degree 2. Then you peel out those with degree 2. And you keep peeling until the whole network peels out. When you take a typical real-world network or a random network and you start peeling it, it peels out pretty quickly in about 3-4 steps. And we peeled, and we peeled, and we peeled, and we kept peeling. And we could go 29 peels deep. And even within the 29th peel, we could keep peeling until it peeled out. So this really bolsters the hypothesis the brain is a very complex and an improbable object that has come into being. So now, all analysis that I've told you is purely structural. We look at a graph and we analyze the graph. A question arose as to if the innermost core seems so special, does it have a functional specification, functional underpinning? So for that, there is a different line of thinking in which monkeys are put into imaging machines and are presented with tasks. There are 2 kinds of tasks, task positive and task negative. Task positive is where monkeys asked to do a very simple task like follow a cross or an arrow or do something very simple. And task negative is when monkeys are left in the machines and they think what monkeys think about. So no task. And there is a very, so let me just jump here. There's a very beautiful piece of work led by Marcus Reichel where they found that the task positive and the task negative networks are anti-correlated in the brain. In other words, when the task positive network lights up, the task negative group of areas is depressed, and so forth and so on. And what we found is that both the task positive and the task negative networks are contained in the innermost core found structurally. This is a very startling coincidence. You have results coming from 30 years of brain imaging studies which are completely functional. They don't open up the brain. And 50 years of work in structural studies where it's invasive, and you find the crux of both these 2 fields and to match up. So it suggests that the innermost core may not be a coincidence and in fact may hold the clues to higher cognition and perhaps even consciousness. So with that, let me switch from neuroscience to supercomputing.